Hi, good afternoon, everyone. Can you open your camera, please? Thank you. Please open your camera. Right. So today we'll discuss about data pre-processing. So you can get the slide in Google Classroom. So, okay, so what we will discuss actually, so actually four things. Yeah? First is general characteristic of data, and then we discuss about type of attribute, data exploration, and finally we discuss about filtering. Well, this is like what we discussed last week, no, 2 weeks ago. Yeah, that the first step in the data pre-processing in the data analysis is data pre-processing, right? So in machine learning, this is what you do. Okay, to clean up the data. Basically, this is like the things that you will do almost all the time, yeah, regardless what kind of data. Okay, so what is data? Okay, so in here we discuss data as a collection of objects and their attribute. Okay, so you look at the figure in the right here, you have a several objects, say 10 objects, and we have attribute of refund, marital status, taxable income, or whether this object, which is the person, is actually cheap or not in their tax. So attribute is a property or characteristic of the object. So for example, the eye color of a person, marital status, yeah, and so on. So when we say attribute in here, sometimes we will say variables, yeah? The field, characteristic. Sometimes we call it as feature. So feature, attribute, variable, field, characteristic are all the same. Yeah. Basically, this is the column of the data table. Okay. Next, we have also a collection of attribute will also describe an object, right? So when we said object here, we also said sometimes as record, point, case, sample, entity, instance. Okay. These are all the same name. Okay. Which is the row of the data table. Okay. So we always put the object in the row. Okay. We put the attribute or the variables in the column of the data table. Okay. So actually there are several types of data set. Okay. So in big picture, we can have a record data. So similar to the data table a while ago, okay, with this relational record, for example, data matrix, okay, document data here in the right side. You can see document data, transaction data. Bottom right side here is the transaction data. So we also have graph data, okay, social network data, the web data, molecular structure data. They are mostly about graph data. Okay. We also have order data, spatial data, temporal data, okay, sequential data, genetic sequence, for example. They are order data. Here are some examples. Okay, so record data that consists of record, which is the row, okay, which have a fixed set of attributes. So then the total number of variables are fixed. Okay, so the attribute does not need to have the same type. They can be binary, refund is binary, right? Marital status here is categorical, taxable income is numerical, and so on. Okay. So when we say data matrix, what's the difference between the record data and data matrix? In data matrix, okay, they have fixed set of attributes with the same type. Either they are numerical or categorical, but not both. Okay. So these are example of data matrix with mostly about numerical data. Okay. Next, we have document data. Suppose you have a document or paper, for example, then you want to analyze the document. Is it possible? Yes, it is possible. Okay, say you have, in this example, you have 3 documents. So in each document, you have word, right? So each word in the document, okay, we will put it into table. And what is the number here? Can you guess what is the number here? Anyone? The number here represents the frequency, okay? The number of times that word occur in which document. Okay? So documents are categorical, words are categorical, right? So if you want to analyze categorical data, what you can do is to get the frequency, how often it happens. Okay. Similarly, with this is the example of transaction data. Transaction data is again word, right? For example, bread, milk. So each record, okay, each row in here represent one transaction, involve several number of items. Okay, for example, in the grocery store, right? So the set of product purchased by a customer during the shopping trips. Okay. So this is the example of the transaction data. So of course, using transaction data, what you will do? Again, we will find the association. How often beer, bread, for example, will be put together with milk. Okay. How often tissue will be put together with vitamin C, for example. Okay. Graph data usually put into XML or HTML. Okay. Usually we can always put them into node and link. Okay. So this is an example of graph data as well. Yeah? Chemical data is graph data. Now order data, this is the example of order data. A and B here represent the items or the elements. Okay. And then you will always have an order of this event or the items. Okay. And that order will be grouped together as well with the parentheses. Okay. Genome data, for example, is just a long string, okay, of 4 characters only 4 characters. Okay. G, T, C, and A. Based on genome sequence data, we can characterize whether this is a monkey or human. If it is human, then we will say they are actually DNA is matched or not. Okay. Different race will have different genome sequence data. Now, this is an example of spatio-temporal data. Can you see the monthly average temperature in the land ocean are changing of different months. Okay, so we have space and we have also time, and we put them together as an animation here. Okay. Another data type is whether they are into a scalar or vector. Okay. Scalar is one-dimensional number. We measure from the origin or 0. Vector is n-dimensional number. Okay. By putting your numbers into a vector, you basically combine those numbers into one, so that's easier to understand. So there are 3 types of vector depending on how you measure it. So one is called vector based on origin. Okay. The second type is a vector at certain point in space, and the third type is a vector with any point in space. They are still all called vector. Okay. So, okay. Vector with the measure from origin, I will throw it here. Say, for example, you have this is 2D vector. Okay, this is your axis. Okay, and this is your origin. Say 0 here. Right. I will throw another color for the vector. So your vector, okay. So your vector is starting from the origin, right? But you can also have another vector here, which is exactly the same length and the same direction at any certain point in space. Yeah. Or the same vector can be in the same line as the origin. So vector can be moved, okay, in the other place as long as they have the same length and the same direction. So always have the same length, represent the value and the direction. Okay. So usually put vector as this kind of notation. So and usually vector are put together with matrix. Okay. So this is an example of rotation matrix counterclockwise. Okay. If you multiply the matrix with the vector, you multiply each row of the matrix with the column of the vector. So example here, cos theta and minus sin theta here. When you put into multiplication, you will have x cos theta minus y sin theta in the first row. In the second row, you will see sin theta multiplied by x plus cos theta multiplied by y. Okay, so I want you to practice this type of matrix transformation. Okay, so you can put any data, x comma y. Okay, and then you transform that data to the mean, meaning you minus with its mean. Okay, and then you create a matrix rotation with this one. This is the rotation matrix. Okay, and next you multiply the matrix of coordinate with the rotation matrix, this one. And this is the one that you will plot. Okay, so first you can plot this one, the real data, and then this is the first graph, and this is the second graph. You will see in the second graph that the value has been rotated. Okay. Can you make it? So you can open Excel and start to type that data. Okay, in the slide, page 16. Right, so I have, so small x, small y, and the two of them are called x capital. Okay, so let me put the same data. So 3, 4, 2, 5, 2, 4, 0, 2, 5, 7, right? 9, 8, 7, 7, what else? Minus 2, 1, 5, 6, 1, 3. Okay, so what you will do, you will get the mean. Okay, how to get the mean? Average, right? The average of this 3.2 and the average of that is 4.7. Okay, so I will put yellow. This is my data, right? Okay, so then I will get the x0, which is the translated, okay, of the x into 0. How do you get that? Okay, for each of these, we minus with the mean, okay? But since I will not change the row of the mean, so I need to put $sign. Then I can copy and get the value. Okay, this is the x0, this is the y0. Then I create a rotation matrix. Okay, so to create a rotation matrix, I will put the theta. Okay, I will put 90. Again, I put this as input, so I put yellow here. So rotation matrix. Yeah. This rotation matrix is about an origin, so that's why you need to put it into 0, 0. Yeah. Rotation matrix. Oh, what will happen to the mean? What will happen to the mean of this one? Of course, it will become 0. This is actually 0. Okay, so I have this one. What I will do? I need to make the rotation matrix. So there, the formula of rotation matrix is, I will name this theta. Okay. So let's make the rotation matrix, which is cos equal cos theta. Oh, the cos must be radians of theta. Okay, this one should be minus sine of the radian of theta. What is this? This is sine of the radian of theta again. And this is the same thing. Yeah, this is the cos of the radian of theta. This is the rotation matrix. I'll put it as number. So we will see the number must be. Okay, let's color it blue. If I change this to 45 degrees, yeah, right, if I change it to 0 degree, oh, I got that. Yeah, if 90 degree, I got that. Okay. So what I will do next? I need to multiply. Okay, so this is called R, rotational ROT. Okay, and this one I will name this as x0. Okay. Then what I will do? I will create a matrix multiplication of x0 multiplied by rotation. Yeah. Is that correct? X0 multiplied by rotation. X0 have how many rows. It has 10 rows and 2 columns. Okay, and rotation matrix is 2 by 2. So then the result will be 10 by 2 again. Okay, so M mode of what? M mode of this X0. Okay, and then multiply by the rotation matrix. Huh? Okay, so once you have this, you highlight it. Remember 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? And then you press F2 and you press Shift Control Enter. So this is the result. Okay, so I give different color, then I can start to plot it. I can start to plot. Okay, so what happens if I put 0 degree there? What happens if, okay, I will make a trend line so that you will see. Okay. So what happens if I make, so this is the original data, is the 0 degree, right? If I rotate this to 45 degree, oh, if I rotate this to 90 degree, it's the same. 45. Okay. The value is not the same. Okay, as if they are the same, but Excel automatically scale it up. Okay, can you do it? Okay, when you finish, you share your screen. Okay? Yes, Canis, what?
Can you hear my voice? Okay.
Okay.
Uh, wait. Wait. I forgot the formula of the rotation matrix, sir.
Ah, it's in the slide. Everything is just in the slide.
All right, right. Sorry. It's shared, yeah. Huh.
Yeah,
Okay,
just
okay.
look,
Yeah,
you
okay,
just
okay.
look on the
I found it.
slide.
I found it.
So I can, for the charting only, I can add new, select data. Okay, so this is like, so I will edit this as rotated. This is the rotated data. So I can add the original data. Okay, this is the original data, but maybe I should name it not original, but zero mean. So the zero mean data is this. So why is this one? And then click OK. Then you can click this one and add trend line. So you can start to see. So let's make it 90 degrees. Okay, so this is supposed to be 90 degrees, so that means the Excel scaling is not so nice. I will scaling it out so that almost 90. Yeah? Oh, too much. Okay, almost. About 90 degrees. Okay, so if I put 0 degree, what will happen? Max. Okay, if I put 45 degrees, so it's about 45 degrees. 90 degrees, so it's between the original and the rotated is 90 degrees. To see how it rotates. So I make it 60 degrees. There. Well, minus 90, the same thing. You just need to scale it so that it's almost the same height. So that you can see this is actually 90. It's a little bit difficult to put exact. Okay, anyway. So once you make it, can you show? And then you will get recitation point. Yes.
Wait. I have found the rot matrix. Wait. How do I like multiply it by XO, YO?
Share your screen, I will help you.
Okay. Wait. That last part. It's never been a while since I use Excel. So let's just say I make it here. So I type do this or
Okay. So that is your rotation matrix, right? Can you make name there so that you will know that it's a rotation? So in the name box here.
name box where?
Yes, this is the name box.
Uh-huh.
Okay. Can you FOP, for example, rotation. Yeah, okay. Oh, no, no space.
Oh, no space. Okay. Let's just say rot.
Okay, rot. Okay. Which one is rot?
This one.
No.
Oh, right. Sorry. This out of this it should be rot. Sorry. I rarely use this. Like this?
Yes, but you already make it, so you need to remove that first.
Wait. Rot. This one is G3. This one is wait.
Menu formula.
Remove for where?
Menu. Oh, no, in your menu formula. Here.
In my water? Oh, formula. Okay.
Okay, and then you name manager. That name manager.
Name manager, define name. Name manager.
Okay, that delete.
To remove.
Either you delete or you edit. That's okay.
Let's just edit.
Okay, let's just edit. then the reference.
This one refers to, should be this one.
Yeah, that 4. Okay, very good. You click OK.
Close.
Close. Okay, and then the X0 you define also.
Mhm.
The whole, no,
Oh,
X0 is,
all of this.
yes.
Yes, okay, sure.
And then you keep name,
New X0.
X0,
Okay,
okay, good, close.
close.
Then you
Then,
multiply.
so,
That one is X0 multiplied by, so M, nah? M.
X0
No,
multiplied
no, no.
by,
Multiply is not like that. It's a formula, so you need to use function.
okay.
Mul. M,
Right, more,
matrix multiplication, that one. MM.
MN.
Matrix multiplication.
Oh, more, okay.
Okay, M mul.
So, this
That
one,
one,
and
comma,
second
that
array.
rotation. Okay, very good.
I see, I see.
Close it. Okay. Now, to multiply a matrix, you cannot just copy that. You can copy, that is wrong.
Oh,
All
I
right.
should make it here, yeah.
No.
Make it here.
To multiply a matrix, what you need to do is to know the size. Okay.
Uh-huh.
So matrix A multiplied by matrix B, yeah, it can be multiplied if the first matrix column is equal to the second matrix row, which is correct, right? The column
Yeah.
is 2, the second matrix row is 2, so this is correct. So it's now the size of the result will be the same as the first matrix row multiplied by the second matrix column. So in this case will become,
So, wait. So in this case, it would become
10 by 2, right?
yeah, 10 by 2.
Okay, so then you highlight first 10 by 2.
Oh,
So you select 10 by 2. Okay, you select 10 by 2. You use shift.
shift,
Shift and then arrow.
10. All of this.
Okay. Yes, using arrow is better than one more down and then to the right. See, no, use arrow is better. Don't use mouse. Use your arrow and shift key and then use arrow to the down and left.
Arrow and shift key and use. Oh my god. Arrow and
No. Don't use mouse.
wait.
Okay, use your arrow, your keyboard. Okay. Shift key.
Shift key.
Shift key and then use arrow.
Use arrow.
And then down.
Okay.
Okay. And then to the right. Okay, one more, right? One more down.
Or down, and then enter.
No, don't enter. Now you use function F2.
Function F2. What?
No, function.
Wait.
That is
yeah. Shift. Wait. Let's do this from the beginning. Function F2.
Did you press?
Wait, function F2 is the F2 in the just the F2. What?
No, function F2. Fn F2.
Huh?
Function F2. F2.
Wait. Function F2.
Can you press F2?
I did. I already did. That's
no,
F2.
you did not do. Oh, okay. If you do, usually it will show, but you do not do it. So, okay. So if you do that, so press Shift, Control, Enter together.
Shift, Shift, Control, Enter together.
Mm-hmm.
And that with F2, yes, sir.
F2 first and then
Oh, F2 first
enter
and then
together.
shift control
That
enter.
one is correct. F2. Shift control enter.
Yeah. Ah, okay.
Yes. Very
Sorry,
good. Very good.
sorry.
Very good.
This is new advanced Excel. Okay.
Okay.
After
Very
that,
good.
shift. After that, you make
After that, you just
where is the
okay. After that is PC. So you just go there. Yes, that one. The insert. That one. The XY.
XY?
XY. I will show you. This one.
Ah, okay. Inside. You mean scatter? Okay. Okay.
Okay, scatter.
Scatter. I know that. That's scatter.
Okay. What happened?
Should be.
Oh, can you put the numbers? And then you can click one of them. One of in the chart, you can click one of the value in the chart.
Mm-hmm.
Okay, right click.
Right click and
Trend line, add trend line,
trend lines.
add trend line. Okay, enter.
But
Finish. You have it. So you just close that.
let's try.
Let's try 45.
Okay.
Okay, but your data is a little bit different from my data. Is it?
Sorry, I'm sorry, sir.
Your data is different.
Oh, because I use run between.
Oh, random. Okay, okay. That's
Uh-huh.
okay. So then you can plot another one if you want. So that you can,
Oh,
so you click your chart.
uh-huh.
Okay, and then where is it? In design, kan?
In design.
Okay, select data and
Uh-huh.
hit that first. Edit,
Edits.
yes, and name it. For example, this is the rotated, right?
Uh-huh.
Rotated. Okay. And
Okay.
then add.
When
Add. You add data. There is add button there.
there is other ah
ADD, add.
oh add okay add sorry
Okay, so this is the X0. So it's up to you to name it.
okay
So the X is X0
mm-hmm. So it's X values should
in the
not
column D2 until D10. You can use your mouse.
uh-huh. Series X values is this
No.
or this one
Yeah, that one.
uh-huh.
X0. And then the Y is the Y0.
Uh-huh.
Click OK. Click OK again. Now you click the orange
Uh-huh.
and then right click,
Right click
add trend line.
add trend lines
Okay. Then you can make it theta 90 degrees.
make it what's that 90
90, yes.
90 okay.
90,
Sure
90 degrees. Okay, now you move that. Now you change the your chart so that it become 90 degrees.
huh
You move a little bit. Okay. That is actually should be 90s, right? But
uh
it inclines, so you resize your chart so that it become 90, almost 90. To okay.
yes
Yeah, it's up to you.
okay
So then you can now you can play it into 45, 0, whatever.
okay okay sir
Okay, yeah.
thank you
So thank you. So anyone else want to share your screen? If you have problem, we can learn together. You know, why I ask you to open your screen, your camera, so that I can see your mimic. If you don't understand, you don't talk anything. I don't know about you, what you are doing, what you learn or not. But if you open your camera, I will know, right? Suppose you don't talk anything, but your expression from your face talk about it, then I will know, right? So at least I need to get feedback from you. So if you have any difficulty, tell me so that we can learn together. Okay. If Ivan, you want to say something?
Ada. Oke, siap.
So I hope with this you learn how to do a matrix multiplication at least, right? I thought you learned spreadsheet in the second semester or in the third semester.
We did, but maybe it's a long time ago, sir.
Oh, forget already.
Yeah, too much information into our head. Wait.
Anyone else want to share your screen? Even if you have difficulty, don't worry. We can discuss about it. Probably the most difficult part that you might forget is the array formula, right? How you get matrix multiplication. Or maybe the charting. Okay, can you open your, I'm not sure if you are there, so can you start your video so that I will know? Okay, Raymond, can you share your screen?
Yeah.
Okay, very good. Wow, very neat. You can add one more chart. Okay, so click your chart. Okay, and then in the design, no, in the design, I think chart design.
This one?
You can add one more data, select data.
Which data should I add?
When you click your chart, then
Yes.
you can select data there. Yeah, and then you can edit the first data as rotated. Edit.
This one?
Yes, edit. Edit. Okay, name rotated that you have rotated, right? And then okay, rotation, okay. And then add. Yes, that one is the original.
The X0.
X0, correct. So the X is the X0 and the Y is the Y0. So you select X0 without the label.
So only this one.
Yes, until down. Okay. Then the Y value is again the same, Y0. Okay. Click OK. Click OK again. Then you can make the trend line for the orange. Oh, very good. Yeah. Okay.
Okay, sir. Thanks.
Thank you. So, anyone else want to share? Putu, you want to share?
I cannot find the X0 times
Yeah.
coefficient.
Oh, okay, show me so that I can help you.
This one.
That I cannot see it. Oh, okay. So X0, can you press F2? Function F2.
Yes, but nothing here, nothing happened.
Okay, that's correct. Okay. Okay. So what you will do is, okay, you go to K3,
K3, okay.
K3, okay, and then press your keyboard Shift key,
Shift key.
yes, and then to the right, arrow to the right, and then arrow down. Okay, until 10 rows, 3, 4, 5, until 10 rows. Is that correct?
Yes.
And you press function F2 and then Shift Control Enter.
F2, Shift, Control.
Function
Wait.
F2.
F2,
Yes.
Shift, Control,
Edit.
Enter.
Yes.
F2, Shift, Control, Enter. Nothing happened.
Your function key is not correct. You see, your function F2 is keep doing something else. How I use function F2 there to edit?
Sorry, sir.
F2, edit.
F2, then
No, you see, if you press F2, actually this is not F2. This is like something else. Like you change the volume.
yes. So function F2 at the same time.
There is a function key, maybe FN,
FNQ,
FN, F2.
FN, F2. Yes.
Yes, okay, that is correct. And then now press Shift, Control, Enter.
Shift, Control, Enter. Okay.
Yes, very good.
Okay.
Ah.
Finally.
Anyone else have a problem with this?
I stop share, yes, sir.
Yeah, it's okay. Yeah.
Okay, thank you, sir.
This is charting only, right? So
Yes.
you know how to do. Okay. Anyone else have this problem? Similar problem, still cannot? I can help you. James, you want to, can you do it or you want to share your screen?
I think I could do it, but I think I had one problem.
Okay, show me.
I forgot how to get it line.
How to create the line? You just click
Yeah.
one of that point,
Okay.
right click. Okay, add trend line.
Oh.
And then, and yeah, okay, finish.
Oh. Okay.
Okay. That's it. You just close that format trend line. You get it.
Okay.
Okay, and then you can add one more chart there, which is the X0.
From here.
Okay, you click that chart, the chart.
Oh wait.
Okay, okay, and then you add, I think in the chart design,
Where is?
in the, or select data there. You have select data there. Can you see the menu?
Which one?
Right click. There, select data.
Oh,
Okay.
I think.
Okay, you need to edit that. So this is like X0, right? You type X0, and then your data is incorrect. So you press the arrow there, and then you highlight it. No, not X0 is E3 until E12.
Oh, okay.
E.
Oh.
No. Yes, that one. And then the Y is the same. F2, F3 until F.
Well.
Okay. Click OK. You got it. Okay. Click OK again. Then you can put the trend line for the orange.
Oh, okay.
Okay, very good. Okay,
Okay. Thank you, sir.
theta, yeah. You can change the theta. So, everyone okay? Or should I assume okay? You can do it. Okay, anyway, I have a recording of this so you can practice again at home if you cannot do it, okay? Okay, let's go to the next topic then. Next topic is the second topic, right? The second topic is about measurement of scale. Okay, let's go. Okay, the second topic is about measurement of scale. All right. So it's a type of attribute, okay? There. Okay. So attribute values are numbers or symbol, okay, that you assign to an attribute. So what's the difference between attribute and attribute values? Okay, the attribute is the variable, right? Attribute values is the value inside the variables. Okay, so the same attribute can be mapped into different attribute values. Okay, so for example, the height can be measured in feet or meter, right? And different attribute can be mapped to the same set of values. So, example, the attribute value for IDs are age and which are integer. Now, what happened is we have what is called measurement of scale. Okay, so you want to categorize, okay, your data type. Okay. So the data type can be categorized into two. Okay. One is called qualitative and the other one is quantitative. So in qualitative, you have nominal and ordinal type. In quantitative, you have interval or ratio. Okay, what is qualitative data? Qualitative data is the data that can be placed into distinct category. Okay, sometimes you can array into some meaningful order, but you cannot do any arithmetic operation. For example, your blood type, okay, either A, B, or 0. Say, or you can put it as assignment evaluation, for example, fail, pass, good, or excellent. So these are categorical data, right? So qualitative data are categorical data or order data. The second type of data is called quantitative data. Quantitative data are numeric in nature. So they can be run in order and they can have some meaningful arithmetic operation. Again, they can be classified into two. One is called discrete or the second one is continuous. Okay, discrete data assume that the value can be counted. Okay, so it has only finite or countable in infinite set of values. Okay, usually we represent this data into integer. That's including binary attribute. These are the examples: zip code, okay, the frequency of the word, for example. Okay, the number of children in families are discrete data, right? Continuous data assume all values in the number of line within the range value. So this is uncountable. Okay? The value are obtained usually by measuring it, and it has real number. Okay? In computer, you cannot represent actual real number, so you put it as floating point variables. Okay. Now, the examples are temperature, height, weight, and so on. Okay. Now, from this four measurement of scale, okay, we can put it into order something like this. The lowest is nominal. Okay, the second lowest is ordinal. The two of them are qualitative data. Okay, the third is interval, and the highest is ratio. Why I said it is the highest? Suppose you want to create a questionnaire survey, okay, for your project, okay, or for your business later, right? So usually you put a Likert scale like this: unimportant, somewhat important, very important, or unsure. So, or very poor until very good. These are what type of data? Nominal, ordinal, interval, or ratio? Anyone? Are you still there or sleeping? Nobody answered. Hello?
Can you repeat, sir, maybe?
If you're in the questionnaire, you use a Likert scale, okay? Very poor, poor, good, very good. So what type of measurement scale you have there? Nominal, ordinal, interval, or ratio?
Maybe ordinal, sir.
Ordinal, okay.
Okay, ordinal. Okay.
Okay, so
Okay.
it is important to know, okay, important to know that Nominal is the lowest, ordinal is the second lowest, okay, interval and ratio. So from the ratio data type, you can put it down to interval, to ordinal and nominal. But from nominal, you cannot put it into ratio. From ordinal, you cannot go up to ratio. Why? Because from ratio, when you put it down, you lost information. I give you an example. Your income. Okay. Say, suppose your income is 2,526,000, example. Okay. Then you put that is ratio type, right? Your income is ratio type. So then you put that into interval. So between 0 to 1 million is 1. Okay. Between 1 million to 2 million is 2. So because your income is more than 2 million, so your number is 3, interval 3. Okay, or you can put it into ordinal. What? Low income, medium income, high income. Okay? Or you can put it into nominal. Example, no income or half income. Every time you put the scale down from ratio to interval, you lost information. For example, from ratio to interval, you lost the information of the detail, okay, which is probably 36,000 of your detail of the ratio of your income, right? If you put it into ordinal, again, you lost another information because you categorize it, right? Become a medium income, for example. So there is a range of medium income, right? If you put it into nominal, whether you have income or no income, then again you lost information. You got it? That when you put down from ratio to interval to ordinal to nominal, you can put down, but you cannot put up. Once you lost the information, you cannot put it up. What does it mean? It means if you create a questionnaire like this, go up to the ratio type as much as possible. If you ask income, don't tell them into the interval. It's easier for them to answer, but you lost a lot of information. Any comment? Look at the example here in this right side. The age is categorized into 19 or younger, 20 to 34, isn't it? 35 to 49. So these are become, the age is transformed from ratio type into, what is this? An interval, right? Or ordinal. So you lost the actual information. For example, the age is actually 25, you put it into category 2, right? But you lost information that is actually 25. You only know that this is between 20 to 35.
So as much as possible, you need it is recommended to use nominal, yes, sir. In a sense.
No, ratio. It is recommended to use ratio because that is the highest.
Right.
Okay. Nominal, you lost information already. You cannot recover that information.
Oh,
Okay.
Okay.
Okay. So nominal are categorical. It is about the existence of choice without any order. For example, gender, right? It is male or female. Then you put male as 1 because all data eventually you will put into numbers, right? You will code your data into numbers. When you put it into computer, you don't put male or female, that's too long. So you will put it as 1 and 2, right? So you can put male as 1, female as 2, or the other way around. You can put female as 1, male as 2. Your assignment to a number does not really make the difference as long as you are consistent with the number. You can even put male 245, which is bizarre. Okay. It's up to you to assign the number of your choice. The second data type, qualitative data type, is ordinal. In ordinal data type, you have order, you have sequence. For example, from hotter until the hottest. Okay, so in nominal data type, okay, you have mutually exclusive. For example, the eyes of the eye color are nominal data type, right? And you need to make the category exhaustive. There is no overlapping between the categories. Okay. In nominal data type, how do you know this is nominal or not? There is no meaningful order, no ranking. Okay. So this is example. The fruit I like is banana, apple, orange. So I can put apple as 1, banana as 2, orange as 3. But I can also put orange as -1, apple as 0, or banana +1. So remember the numbers here, yeah, in nominal attribute, the numbers only symbol. There is no real meaning. Just assignment. You got it? When your data is nominal, and then you put them into numbers because you put them into numbers in the computer, right? So that numbers mean nothing except assignment. Okay, 1 represent apple, for example. The assignment is your lookup table. So here, again, I put, for example, the gender is another nominal data, right? So 1 is male, 2 is female. I can change anything on the labeling, okay? So 5 is female, 225 is male. It's fine, right? The actual numbers have no meaning aside from the assignment. Okay, put representation of 1 male, 2 female, and 5 female, 225 males. Both are valid as long as you have consistent definition. Okay. Is there any question about nominal data? Okay, those who did not show your camera, I will call the Arya Daksar. Can you give example of nominal data? Are you still there?
Yes, sir.
Okay. Can you give?
Sorry, I cannot start my video.
That's fine, but you need to answer that. Give me an example of nominal data.
Is it like the PPT?
Hmm?
Is it like the PowerPoint you showed now?
No, you need to find your other data.
Oh, another example. Okay.
Hmm.
Hold on.
Hmm.
Let's say economic university student and engineering university student.
Very good, very good. Okay. Ivan Kurniawan, can you give me another example of nominal variables? Are you still there? So probably you're not there. Okay. Ivan Ricardo, are you still there? Remember, this is recorded, okay? Okay, you're not there. Anyway. Okay, so the next data type is ordinal data. Okay, ordinal data is a measurement of scale. Okay, that put into category that can be ranked. Okay. The difference between rank cannot be calculated by arithmetic, so you cannot subtract or add. Okay. These are the examples of ordinal variables. Okay. Number one, you put comparison index. For example, you put -2, I strongly disagree. Okay, this is Likert scale. -1 is disagree, 0 is indifferent, 1 is agree, 2 is strongly agree. So comparison, right? Second is rating. For example, 1 is very dissatisfied, 100% very satisfied. So again, the rating of satisfaction is ordinal variable. The third one is ranking. Okay. For example, 1 is the best, okay, and then higher values represent the lower importance. The third one is the last example of ordinal data is ordering, which is the sequence of label based on the rank. This is example here. Okay, what's the difference between rank and ordering? So my preference of fruit vectors are grape, mangoes, banana, apple, orange. So I put that. Okay. And suppose I make a rank there. My rank is for grape is 5, mango is 1, okay, banana is 3, apple 4, and orange 2. So my rank vector become 5, 1, 3, 4, 2. My ordering vector is what? Now you sort, okay, you sort the label based on the rank. Okay, the ordering now become mangoes, orange, banana, apple, grapes. Can you see the difference between ordering and the rank? Okay, the rank still have original order, okay, but you just put the rank inside. The ordering is the actual vector, but you already order it sorted by the rank. Okay. So, okay. Anyone want to give example of ordinal data that is not in my slide? Give any example. Jessica.
Yes.
Can you give example of ordinal variables?
About someone pretty, average, and ugly.
Okay, that's good. Okay, so there is a ordinal value about the prettiness or beautiful.
Yeah.
Yes. Okay. One more. So who can give me example of ordinal variables? Yes, feedback rating data. Okay, very good, Hazel. If your income, can you put it as ordinal variable? If you want to put your income as ordinal variable, how are you going to do that?
Maybe medium income, low income, like that, sir.
Yeah, okay.
Uh-huh.
So, economic, yeah. So, question now, if you become the sportman or woman in the Olympic, you get a medal, right? Bronze, silver, and gold. Is that ordinal variable or nominal variable? Bronze, the medal. Bronze, silver, and gold. Is that ordinal or nominal?
Ordinal, probably.
Why?
Just guessing.
No.
I think it's because the order matters.
Yes, correct. So it's ordinal, even though the naming is look like nominal, okay, the meaning has order, right? We assign the meaning, human. So it's not robot who assign the meaning. Okay. Okay, next. Quantitative data. Okay, either interval or ratio. How do you distinguish quantitative data and ratio? Is this. In the interval, you can add and minus, but you cannot divide. There might be zero in the interval, but the zero has no meaning. Okay. Ratio data type have zero, meaningful, and can be divided. And can be divided. So interval data is a measurement of scale of run data, and the difference between unit can be calculated by arithmetic. Okay. Zero in the interval level of measurement does not mean nil or nothing as the zero in arithmetic means. So the zero here has another meaning, not actually nothing. In that case, it is an interval data. Okay, example here, Fahrenheit. Okay, Fahrenheit temperature has meaningful difference. You can add minus. So 1 degree Fahrenheit has certain meaning. Okay, it has order, right? But the 0 degree Fahrenheit does not mean that it has zero heat. Okay, 74 degrees is 2 degrees higher than 72. That is correct. Okay, so in that case, Fahrenheit temperature is an interval data. Okay. If your temperature is measured as Kelvin, that is ratio. So ratio data type or ratio measurement of scale possess all the characteristic of interval, and there exists zero, which have the same meaning as nil or nothing. As consequence, the true ratio exists between different units of measure. So usually if you want to know with this ratio or not, check the unit. Okay. Okay. So look at the way we measure the attribute. Okay. On the left side is the actual length in ratio. On the right side, okay, is the ordinal measurement of scale. So this is what I mean by loss of information. Okay. 15 is the length, okay, but in the ordinal you will just put it as 5. Okay. 10 is the length. In the ordinal, you put it as 4. Okay. The same thing as, for example, the length is 8. Okay. The actual length is actually 8 centimeter, for example, or 8 millimeter. And then you will put in the ordinal as 3. So the order is still there in preserved, but you lost information about the actual length. When you translate from ratio to ordinal, you lost information. Okay. So these are other example of the type of attribute. Okay. So ID numbers are nominal. Okay. Eye color, zip code. Okay. The ranking, your grade is ordinal. Okay. Calendar is interval. Right. So temperature in Kelvin, length, time, frequency, the count are actually ratio. So now give me example of ratio type. Anyone? Michael Anjaya, can you give me example of ratio type?
With a ratio type.
Ratio measurement of scale. Can you give me example?
Weight in kilograms.
Yes, weight in kilogram. Very good. Nicholas, can you
Height.
give me example of
Height.
okay time? Okay. So, what is the power of measurement of scale? I told you already. Okay, the nominal scale is the lowest level of measurement. Scale, it is the least powerful, that it provides the least information about your data. Okay, ordinal and interval is higher, and ratio type is the highest. So any data conversion from the higher level to the lower level will lose information. Now, how do you distinguish the four attribute type? Okay, check if there is distinctness or not. Okay, whether they are equal or not equal only, that is nominal. If there is distinctness and order, which can be ordered as lower or larger, okay, yeah, smaller or bigger, that one is ordinal. Okay. Now, if you can add, you can minus, okay, you can subtract, you can sum, okay, that is interval. Okay. If you have all of those four properties, they are ratio. Okay, yeah. So this again, the example of the four attribute type, and look at the operation here. Okay, in nominal you can have mode, you can calculate entropy, you can calculate the chi-square test, yeah, contingency correlation, but not the real correlation, not the person correlation. In ordinal, you can calculate the median. You can calculate the percentile, the rank correlation. Okay? You use sign test, run test to do the data analysis. Okay? But don't use mean, arithmetic mean, or standard deviation in ordinal data type. Important, right? If your data is nominal, don't use mean, don't use standard deviation. Why? Because there is no meaning of that mean. You use median. Okay. If your data is quantitative, either interval or ratio, then you can use all the others. Okay. So depending on your attribute type or measurement of scale, then the way you analyze your data will be different. That's why to know the attribute type is the most important first step in data analysis. Okay. So next is the transformation. Okay. If your data is only nominal, what you can do is only permute the value. Okay. Exchange one and the others. Only the location, assignment only. If you have ordinal, okay, you can preserve the change of value with any function as long as the function is monotonic function. Okay. For example, logarithmic, you can do. But if your data is interval, okay, then you can multiply and add. Okay. And if your data is ratio, you can scale it. You can scale it as another value with some scaling factor. Okay, the transformation of your data will be different also. Okay, so this is the algorithm to know whether your data is nominal, ordinal, interval, or ratio. So 3 questions. Is there any ranking? Is there any arithmetic operation? Is there any arithmetic zero? From these 3 questions, you will be able to see whether they are nominal, ordinal, interval, or ratio. Okay, from the yes and no. So until here, is there any question? So this is just the summary that we just discussed. So what do you think? The first step is to know the data type. Okay. Next, let's go to the next topic. If you don't have question, I will continue. So data exploration. Before you do machine learning, AI, right? You need to explore your data. Okay, this is like pre-processing analysis. Okay, make use of your human ability to recognize the pattern. Okay, so you as human can recognize something that your machine cannot capture. That's why this is very important part in AI, because you should be able to beat your AI, isn't it? Okay, so our discussion will discuss about the summary statistic and pattern in distribution. Okay, when I said statistics, what are they? Okay, basically 2 things. Okay, one is to summarize the properties of your data, okay, which is the frequency, the location, and the spread. So let's say you want to do only the 2. One is the location of the central tendency, which is mean, median, and mode. Second, you want to do the spread, the variation, okay? Then you can calculate the standard deviation, interquartile range, or the range itself. Okay, so most summary statistics, okay, can be calculated in single pass-through of the data. So if your attribute is actual nominal, what you can do is frequency, mode. What is the most often, most frequent attribute values are called mode. Okay. And then if you have a data, the most important part that you need to do is to create what is called histogram. Okay. For each variable, you try to draw the histogram, something like this. Okay. In the histogram, on the horizontal axis, you have your value. Okay. That is the variable that you have. In the vertical axis, you have the frequency, how often that value happens in your data. Okay. The next, if your data is continuous, you can calculate percentile. Okay. So if your data is continuous, you can use percentile. What is that? Given an ordinal or continuous attribute X and a number P between 0 to 100, okay, the P percentile is the value of XP of X, so that P% of the observed value of X is less than XP. For example, if you said 50 percentile, okay, so X50 here, that means 50% of the value of X are less than X50. Yeah, X50 in here is the median, right? So The mean, arithmetic mean, is the most common measure of the location for set of points. Yes, Kimberly, you want to say something? Okay. So the problem is the mean is very sensitive to outlier. Let's try this, okay? Let's open your Excel. So I want to share my screen of Excel. Okay. Say, let's say your data is 2, 3, 4, 2, 3, 4. Okay. Now let's get an arithmetic mean, which is the average, right? The average of your data. And then let's get the median of your data. So this is mean, this is median. Okay. So this is your data. Can you see? Now, what happened is, if one of your data you mistype, instead of 2, okay, you mistype as 200. What happened to the mean and what happened to the median?
The mean will increase, but the median probably still the same.
Yes.
Not much of difference.
Correct, Jefferson. So the median increased a little bit, okay? But the mean increased so much.
Yes.
Yeah, this is what we mean by sensitive to outlier, okay? So there is an outlier with this anomaly, either it is anomaly, okay, which is true, but it happened very rare, or this is mistype, right? The mean suddenly jumped, while the median only increased a little from the original. So that's why we say that median is robust. The mean is too sensitive, okay? If possible, use median rather than to use mean. That's the lesson, okay? So, okay, next. Let's come back to the slide. So, usually the central tendency are measured in either mean, arithmetic mean here, median, or mode. Median mean you sort your data and then you get the middle. Okay, the middle position of your data after you sort. Mode mean what? Mode mean the most frequent values in your data. Okay, so there is an empirical formula that mean minus mode is equal to 3 times median, mean minus median. This assume, okay, this formula assume that your data is normally distributed. The second measurement of your data is, of course, the spread, okay? The variation of your data. First, you can check the range. What is range? Range is the difference between maximum and minimum. Okay? If your data is quantitative, you can calculate the variance or the standard deviation. Again, variance and standard deviation is similar to mean. Okay? They are very sensitive to outlier. Okay? So if you want to make it robust, then you can use either AAD here, okay? Average absolute deviation. Okay? The formula is there. look at, instead of you square it, now you take the absolute value, or you can use the MAD, okay, mean absolute deviation. So the formula is again there, which is each of your data minus the mean, okay, and then you take the absolute value, and then you take the median of that, or the interquartile range. So interquartile range mean you calculate the 75 percentile and 25 percentile, and then you take the difference. Okay, so the measurement below is actually less sensitive to outliers. Okay, so to plot that, okay, you can also do a plotting, okay, of the outlier. So we can use what is called box plot. Let me draw. Okay. The box plot is just a plot of your data. Okay, sometimes you have a whisker here that represent the outlier. This one is your median, 50 percentile. Okay, and then this one have certain formula, depends on the interquartile range and Q1. Usually Q1 minus 1.5 IQR. Yes, in here is Q3 plus, yeah, 1.5 IQR. Okay. Oh, here, this one. This one is a Q1 and Q3. Oh, correct, sorry. This is the minimum, this is the maximum, and this is the minimum. Right, so this one is the Q1 minus 1.5, and here is the Q3 plus 1.5 IQR. Then you can plot this data as what is called box plot. Okay. By looking at the box plot chart, then you can start to see, oh, is there an outlier or not? Okay. If your data is numerical, quantitative, either ratio or interval, you can calculate what is called Pearson correlation coefficient. Okay, the value is between -1 to +1. Okay, this represents the angle between two factors x and y. Okay, x is your independent variable, y is your dependent variable. Okay, so x dot y here is represent xi times yi, and then you sum. Okay, and at the bottom is the norm. The norm means you square of x, then you sum, square of y, then you sum, and then you take the square root. Huh? So based on the correlation coefficient, you can see if your data is positive correlation, something like this, or negative correlation. So look at it. Positive correlation mean what? Positive correlation mean the larger your x, the larger your y. Okay. Negative correlation mean the larger your x, the lower your y. Okay. Now, each row in your data, okay, each row in your data, X comma Y here, okay, is a point, right? Each row is a point in the variable space. What are the variables here? X and Y. Okay, so then you can say your X and Y is something like this. Then you can center your data. A while ago, you just practiced, right? You center your data. How do you center the data? You just practiced a while ago. How do you center your data? What the meaning of center data? The meaning is your mean and median, the mean of your data will be in the 0, 0. That means centering the data. Huh? How do you do that? Of course, you minus with the mean. Okay. A while ago, you just practiced, isn't it? So the effect of centering data is the mean will be 0. You only save the mean. The pattern of your data and the spread of information are the same. Only the mean saved to 0, 0. Okay. So the standard deviation, the variation, the correlation will not be changed. Another way to look at your data is not to look at every row, but to look at every column. So each column is a point in object space. So earlier we have what is called variable space or feature space. Okay. The next one is you have what is called object space. Okay. A point is represented by a vector from the origin. So the number of vectors represent the number of variables. Okay. So you measure from the origin so that it will work with the center data. Remember, when you want to do this, you need to center your data so that we can measure only the variation, not the central tendency. Okay. When you use a vector as an object space, what will happen is the vector length represents the standard deviation, relative standard deviation, and the angle represents the correlation. So this is your data. If you calculate the standard deviation of X become 2.1, the standard deviation of Y become 15.1. Okay. And then if you calculate the correlation of XY becomes 0.876. Okay. The arc cost of that 0.876 is 28.9 degrees. What does it mean? Meaning, if you put it as object space, now you represent the whole data set here as just two vectors. What are these vectors? Vector X, it is the red. Say I put it as horizontal. And vector Y, which is the green. How do I represent it? Remember, there is angle between the two vectors, right? So the angle is 28 degrees. So I measure 28.9 degrees. Okay. So this is the X. And then I measure 28.9 degrees. I get the Y. And then I measure the length. Okay. The length of X is 2.1. The length of Y is 15.1. That means the length of Y is 7.3 longer than X. Do you understand or you don't? Or you want to practice so that you know? Okay, let's practice, okay, so that you will know. You type this data in your Excel. You calculate the norm of X, you calculate the norm of Y, can you? And then you calculate the correlation and arc cost. And then you draw the vector. Can you do it? Okay, I create a new sheet. And then I type the data, right? It is X and Y. Okay, X is,
Sir,
yes,
do you share Excel?
yes.
Oh no, it's not.
It's not Excel. It's a picture.
Okay.
I will share my screen. Where is that? I will share my screen. Yeah. 3, 3, 4, 4, 5, 5, 6, 6, 7, 8. Right? So, and then 25, 25, 23, 28, 32, 32, 37, 45, 40, 50, what is that? 55, 75, and 52. Okay. So how do you calculate the norm of X? How do you calculate the norm of X? The norm of X is symbolized like this, yeah? Okay, norm of X. The norm of Y is symbolized like this. Norm of Y. Okay, this is the norm of X. Norm of Y. What is norm? You remember?
Normal distribution, maybe?
No,
Oh,
no,
no. Okay.
it's not a normal distribution. Okay, norm is, I already give the formula here. Okay, so you square the X. Okay, so I will put this. Let me move here. So I have an X squared and I have Y squared, right? So square this. There. So what is the norm of X? The sum. Okay, the norm of X is square root, right, of what? The sum of all these. Okay. The norm of Y is the square root of the sum of all of this. Yeah. Oh, one more. Yeah, correct. C and T, correct. Okay. So now I want to calculate the R. Right? Oh, I need to get the X times Y. Okay, I need to insert one more column here. In here is XY. So then X multiplied by Y. Okay. Right. So how do you get the R? And I will get the sum here. The sum is the sum of this. And so the norm of X. The norm of X is the square root of this sum. With this, I already calculated, it is this one. Square root of this sum. Okay. Same thing with the square root of y squared. So this is the norm of y. How about the R? Person correlation coefficient. This is equal to the sum of x times y, right, divided by, okay, this norm, okay, multiplied by the norm of y. Yeah? Oh, there, I got the correlation, coefficient correlation. Okay, and this one is equal to cos, right? This is equal to the cos. This is the cos of theta. Cos of theta, yeah, equal cos of theta. Then what is theta? The theta is r cos. Yeah? R cos of that value, which is in radian. Yeah? This is in radian. So then if you want to put it into degrees, so you can put degrees of that value. This is in
Degree, yes.
okay. So again, this is theta. Huh? Then if you want to draw the vector, okay, if you want to draw the vector, I will insert, okay, the vector, for example, this is x, right? Okay, let's make it x here. Okay, let's make it thicker so that you know this is x. And I have another one. How many times? This one divided by this one is 8 times. Okay, so if this is 1, I need to get 8 times of this. 2, 3, 4, 5, 6, 7, 8. So this is the vector y, right? And then the degree is 11. Probably like this. Okay, let's make it. So this vector y represent the 8 times of x. Yeah. So this is x and this is y. Yeah, and the angle between the two vector is 11.4 degree. Huh? Any question?
No.
And actually that is the same as standard deviation. Yeah? So I will put here screen sharing in the standard deviation of x, STDP, yeah, of x. Yeah. STDS. Okay, standard deviation have a number of theta, so this is not number of theta. This is the standard deviation of STDP of y. It's very big, so this one divided by this one is a little bit much bigger. Yeah? Oh, the data must be corrected to 0. This one must be minus. Oh, that's why. Oh, wait. This is wrong. Why is standard deviation of C? The norm of X is this one, correct? But the standard deviation is standard deviation of X with this A. Okay, and this is the standard deviation of the P of Y. So about 7 times. Yeah. The difference between the norm and the standard deviation is in standard deviation you divide by the number of data, right? The norm you did not. That's why a little bit different. Okay, so here is 7 times, this is like 8 times. Okay. So the two factor here, X and Y, okay, represent the whole data set in one column. X is represent the whole data set in one column, Y is represent the whole data set in one column. So if you have 2 columns, you have 2 factors. If you have 3 columns, you have 3 factors, and so on. Until here, is there any question? So you have two ways to represent your data. Okay, one is you're using your real numbers, which is the actual data XY. This is called variable space. Another one is to use every column as one vector. In variable space, every row is one vector. Okay, every row in the variable space is one vector. In object space, every column is one vector. Clear? Yeah. So until here, I guess. Okay. So next meeting, can you read the slide of data processing so that we can finish it as soon as possible? Yeah, data pre-processing. Yeah. So next we talk about distribution, right? And then about the covariance, and then filtering. Okay.
Guys, let me share the apa?
Okay.
QR. Wait.
The QR, yeah, for
Yes,
that.
sir.
So can I give you assignment? The last page of your slide, data pre-processing. There are 2 assignments. One is individual, the other one is group.
The group is the same, yes, sir. For is the
Group
same as
means-
the
Is-
sorry?
The group is the same as the individual.
Yeah, that's what I mean.
Is in the group you need to create the code. In the individual you can just use Excel.
Okay.
Right? In the group project, you need to create a code, meaning that you do it in a programming language, not Excel. So in 2 weeks for the group, huh?
Okay, sir.
Okay.
Guys, are you done for the QR? Or
Okay, good. Thank you very much.
Okay, thank you, sir.
Yeah.
Thank you, sir.
Thank you. See you next week.
Thank you, sir.
Okay.
So the assignment is only the group one or both?
Good. But if you do the group one, the first one is easier, meaning just change the number.
Okay.
Okay.
Both in 2 weeks.
2 weeks.
All right.
Okay.
R,
Done?
I think he's done. Okay. Oh, he's done, sir. He just lined me.
Okay, thank you.
Okay, thank you, sir.